You've actually, this is 5354 day 2. You've actually had these already. We've actually done these and tested you on these. And I don't think you have to write these because all it is just the reversal of cosine of 90 minus theta equals sine of theta. Then, of course, sine of 90 minus theta equals cosine of theta. That's all this says. They can be switched. Oh, no, and actually it's the brothers and sisters. Sorry. So I guess you could write that down. That's what this is. I guess you don't have to write these. That's the switch. That's the switch. And that's the switch. They're true. I'm just saying, write your notes shorter. Now, of course, 90 degrees is the same as pi over 2 when you're dealing with radians. And yes, you have been tested on this before. And you'll recognize the question. I'll show you exactly what question was on a test. I think it was chapter 1, actually. Okay, we should be done writing those 3. And then, of course, we know what this means. This makes me angry, students that don't know this still. What's the sine of 30 degrees? Fast. 1/2. Did you hear your friends? Sine of 30 is a half. So what does that mean the cosine of 60 is? That's weird. It's a half because the sine of 60 can't be a half. So the cosine of 60 is a half. We're so used to those ratios because we've done them a billion times. That's how that works. Because a 60 and a 30 make the same triangle. 30, 60, 90s, blah, 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 blah. Okay, so that's what this rule says. If I plug in 30 for theta, let's say, 90 minus 30 is 60. The cosine of 60, which is a half, equals the sine of 30, which is a half. Right? So on and so on and so forth. Any angle you plug in, this is true. All right. So let's move down. So let's answer these silly little questions. Okay, now notice what it says. This is called the cofunction identities. You won't have to have these memorized. There is a quiz on the calendar tomorrow for formula recognition, let's call it. So the ones that we did yesterday, I told you. And watch. When I ask you what's the formula, listen to how many people know it. So you're just not on the bus if you can't memorize. It is a skill that needs to be done. But anyway, these won't be like something you have to write down or match, but I may have you use them. Think about that. So what's the answer for theta? What's theta? What's theta got to be? 65. It's simple. These have to be complements. Ooh, this one's not so simple. What's theta have to be for this one? Not 60. Huh? I couldn't hear you. Oh, and then she's not talking to me. She said a number and she's like, don't talk to me. Huh? It's 120. What's 120 plus negative 30? 90. They're complements. So these are Mickey Mouse examples to start off with. Blanks. Fill in the blanks. Okay, as you're writing this down, I know you like to write the words and stuff. As you're writing this down, what's the blank? Cosine. I can't help you on this. Oh, don't answer so quick on this one. This is a trickster. What's the blank for this one? I heard him whisper it. Don't say it anymore. Anyone else? Well, actually, it should equal what? Tan of 24 should equal what? What's the one it's related to? Cotan, and cotan of who? The complement, which is what? Just look at that number right there. And then what's the cotan of 66 equal to? 1 over tan. So whoever said tan was right. I don't know, just a little trickster question. The idea last hour is to make a phone actually look like a calculator. Isn't that great? So, no, it's just my calculator. And then you're going like this. I'm just calculating, Mr. Samulus. And all you're doing is texting. Instagram crackering. And what's the other stuff? Face spacing and my booking and all that other things that we can do. All right, anyway. Hey, what do we know about this? Let's not get off topic. Come on. Pay attention. What can I do about these? This is the question you already been tested on. This is chapter 1. If sine of an angle equals cosine of another angle, what does that mean about these two? They are what? They're not equal. They are equal to 90 when added together. So this is what you were already tested on. I could pull out the chapter 1 test and show you and prove you this. We've already had these identities. Okay, and then you simply solve. Add 10, Hundo, divide by 3. Fractions. Okay, that's 33. Is that 33 and a third? What is 100 divided by 3? 33 and a third. That's what I thought. Then this one, not so much. We could do what I said there. The rule is cosecant of an angle equals secant of its complement. But what I thought is, theta has to be pi over 2 minus 3 pi over 4. Right? Pi over 2 is the same as what degrees? Say it. 90. Okay, oh no. And then what do I got to do? I got to get a common denominator. And then what's theta equal to? What's 2 pi minus 3 pi? Negative 1 pi over 4. Whew. I do feel lightheaded. Needed to. I'm going to be perfectly honest with you. These are silly questions. This is a silly question just to get you to exercise. Look up here, sir. Silly questions just to get you to memorize your formulas. Now listen to your friends. We're all friends in math. Okay? When we actually try to fill this out. But before, I'll show you common errors. And if you are staring at ceiling tiles, or like someone last hour, he read all 7 posters in the back during my notes. Got all those figured out during the notes because I took his phone away because they had to put the bag on the floor. They had to do something else other than look at the notes. All right? This is the only way you can screw this up. Okay, first things first. What's n? Is it an angle or is it a ratio of sides? What's n? It's an angle. You always get these questions right. Be proud of your throwing answers out there. So what's that make 15 over 17? Ratio of sides. You cosine an angle to get a ratio. And then what does that make t, of course, everybody? An angle. And then negative 24 over 25 is what? Ratio of sides. Okay, so just understand that. Second thing, we're all going to do this together. It actually worked out second hour, even though second hour doesn't like talking to me at all. I ask the question, hey, how was your weekend? They just stare at me and drool. It's very awkward. All right? What's the rule for cosine of n plus t? Stop. Ready, set, go. What's the first thing? Cosine what? N. See, now you're worse than second hour. What's the next thing, everybody? Cosine t. There they are. What's next? Minus. It's just the rule, right? And then what's next? Sine n. Sin. And then what else? Sine t. Okay, so it's really easy. Over half eventually got on the bus and actually said what they need to say. If you don't know this, I don't know where you're at. You're in a different world. By the way, do we have cosine of n already? Yes or no? So it's just a silly question that gives you some information about n, and then they ask you to add, what's this silly thing for this situation? What's the sum of these two angles, the cosine of that sum? Well, it's the formula, and I do have one part. Do I have this part? Yes or no? No. Do I have this part? Yes or no? Do I have this part? Yes or no? So you have 2 of the 4 parts, and now I'm going to tell you what I get all the time that's wrong. I get people put the word cosine in front of this. And I get people that put the word sine in front of this, and they put the word sine in front of this. Why is that completely and totally, mathematically, syntactically wrong? Wow, that's a lot of adjectives. Why is that wrong? Because you can't sine a ratio. You can't cosine a ratio. You've cosigned an angle and got the ratio. You putting the word cosine and sine in front of this tells me you don't know what you're doing. You're just trying to grab at a formula, and put some stuff down. It's wrong, and I will mark you wrong. So quick, your head will be what? Bless you, my friend. Okay, now, how do we get the other ones? Guess what I'm going to draw, everybody? Now, look at what they say. You're lucky they gave this information. They're in quadrant what? 4. So I got to draw this triangle in quadrant 4. And by the way, does this work? Is cosine positive in quadrant 4? Yes or no? Well, of course it is. Does anyone know that x is 15 and r is 17? What y is immediately? Oh, you don't know your triples. It's not 18. You were close if you get rid of the teen. 8. But is it 8? It's actually negative 8. because it's in quadrant 4. I didn't know that. Well, guess what? Do the Pythagorean theorem. I'm not teaching it anymore. X squared, 15 squared, plus y squared equals 17 squared. Solve. Not doing it. Okay, then over here, let's put this triangle. By the way, this is N. I'll put it as capital. This is angle T's triangle. Does anyone know 24, 25? Blank 24, 25. I'll give you a hint. It's not 3. Now we're just grasping at numbers. Here's R. Here's Y. 7 is right. Did you remember that? You just did it real quick. You guys don't remember 7, 24, 25? It's one of the 4 I listed way back in chapter 1 or 2 whenever we talked about trig of common Pythagorean triple triangles. 3, 4, anyone? 5, 8, 15, 17. I got one, 5, 12. Come on, everyone usually knows that one. 5, 12, 13. And then the last one was 7, 24, 25. You might want to write those down again. By the way, what's the cosine of t now? What's the cosine of t? 7 over 25 minus. And then what's the sine of n over here? Sine of n. Negative 8 over 17. All right? So these are just silly little formula questions. Can you fill in the numbers in the formula appropriately? Now, what a jerk. I can make this no calculator. All right? I don't need this anymore. Step 2. We're doing the steps. There we go. Good. All right. What's 15 times 7? Well, hold on. What's 7 times 10? Just answer that question. What's 7 times 5? 35 plus 70 is what? 105. And then, gosh forbid, I make you do 17 times 25 without a calculator. Be like my 4th grader in 3rd grade when she actually did this. Multiplied. But I don't even need to do that. What's 10 times 25? What's 10 times 25? 250. And then what's 7 quarters that you give to the lunch lady or man? How much is 7 quarters? How many pennies is that? $1.75. 100 plus 200 is 300. 50 plus 75 is another 125. Have I blown anyone away right now? What's the final answer? 425. That's mental math, everybody. Minus. What's 8 times 24? No. What's 8 times 20? What's 8 times 20? 160. What's 8 times 4? 32. 160 plus 32 is what? 192. Then what's 17 times 25? 425, folks. What's 105 minus 90? What's 192 minus 100? What's 192 minus 100? 92, but it will be negative later. But what's 92 minus 5? We're just trying to get the difference between the two numbers. 92 minus 5. 87, but it's negative because it was 105 minus. Whoa. I'm an alien. That's why I'm able to do that. Okay, hold on. You don't even know what I'm talking about on YouTube. No one's listening anyway. Here we go. Sine of a plus b, tan of a plus b. Then I have a real rich question after this. 5354. Okay. So, sine of a equals 4 over 5. Wait a minute. Where is a? What does that mean? That's now cryptic information. What quadrant is that? This is in quadrant 2. Is that possible? Is sine positive in quadrant 2? I heard someone say yeah. All right? And then they're just giving you information. They're trying to be cryptic. And then cosine is negative 5 over 13. Where's cosine? Where's b located? What quadrant's that? 3. It looked like I saw lightning out there. Or someone just took my picture in the back with their phone. Ooh, thunder. Okay. By the way, here we go, class. Sine of a plus b. How does it start? Ready, set, go. Sine a. What's next? Cosine b. What's next? Plus. I like doing that too. You can switch those two, but I like doing this because I already did the sine of a, so now I got to do the sine of b. I think it's the easiest way to write it down. And then just to get this done, what's tan of a plus b? Tan of a. What? I didn't hear the middle. Plus, Jacob. Oh, you're online now. What are you doing over there? Then what? Looked like you flashed a gang sign or something to your friend back there. Well, that's why I was worried. You were doing like some fingers or something. Not in my class, not on my watch. Where's angle A? What quadrant? It's actually 2. And then, oh, come on. 4, 5. Anyone know what X is? You went the wrong way. 3. But is it 3? 6. Goodness. So many things wrong with that answer. You're not supposed to say that to a good answer, little whatever your name is, but it's not right. Sorry. Didn't mean to crush your dreams. All right, then what? Negative 5, 13. Anyone know what the other side is? We mentioned it today. 12. Hey, and if you don't know it, do your Pythagorean theorem. I'm not here for that anymore. What a mean guy. Okay, so now this one. What's sine of A? Well, I think that one's given, folks. What is it? You put sine in front of that, I'm marking you wrong. I already said that. What's cosine of B? That one's given. So you at least know what you can fill in 2 of the parts. Plus, now what's sine of B from our drawing? Negative 12. I don't have the time. Someone's got to get their homework done in another class, so I got to get done with my notes. I'm under pressure now. Under pressure. Dun, 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 dun. Cosine of A is negative 3/5. Okay, then we'll finish this one off. We'll go to the other one. 4 times negative 5. I'm not going to bore you with the mental math. Okay, I will. 5 times 10 is 50. 5 times 3 is 15. 50 plus 15, 65. That's certainly allowed to be on a no calculator test. Give me a break. 3 times 12 is 36. They're both negative over 65. And then this becomes 16 over 65. Then I'll zoom back. And then luckily they say tan of A plus B. Well, not luckily. But luckily for my last question, which is really cool. I'll show them all at the end if you didn't get this done. But what's tan of A? What's tan of A? Here's A. What's tan of A? Am I going too fast? Well, someone's got to get their homework done for another class. I got to get this over with. He's giving me looks of death. And I got to get it done. Or else. All right, tan of B. 12/5. 1 minus these 2 again. Now, this is going to be weird. I'll just verbalize this, but then actually do what I want to do. Because it's my class. All right? You could go ahead and get a common denominator and a numerator, add them. And then get a common denominator and a denominator. And actually add them, because minus and negative, right? And then go ahead and divide, flip. You know, do the divide, flip thing. I'm not doing any of that. I'm going to get rid of all these little fractions right off the bat. And because of time, you are correct. I'm going to multiply both of these top and bottom by a Godzilla Gargantuan 15. And those that don't understand fractions, you still make me mad. Okay? And if you don't get this, it's your own fault. Because when I throw a 15 in there, all I have to think is, how many times does 3 go into 15? 5. What's 5 times negative 4? That's how fractions work. It's as simple as that. 4th grade. When I throw a 15 here, 5 goes into 15, cross-canceling. How many times? What's 3 times 12? No time. It's 36. Don't forget this, though. It is 15 times 1. That is the most common error trying to do this quick way of getting rid of denominators. And then this is 3 times 5, which is 15. 15 over 15 is 1, so all I have to worry about is negative 4 times 12, which is what, of course? Negative 48. Now look at all the little fractions are gone. And then I'll zoom back for those that didn't get to see all of them. This ends up being 16, right? And then over, careful, it's minus a negative, 63. Hey, now I have a question. You should be able to answer this question after you look at this. You should be able to answer this question in 1 second after I'm done writing. What's the cosine of A plus B? 1 second? I have to do all that rule? No, you don't. The answer is staring you in the face. Psh, psh, psh. The answer is staring you in the face. What? No. No, it's 16 over 63. No. What? I thought I heard it. Boom, shaka, laka. Why is it 63 over 65? Because A plus B is the same angle as A plus B, which is the same angle as A plus B, which means they have the same X, Y, R values. This is Y over R. This is Y over X. Cosine is what? X over R. X is right here. R is right here. Say I asked A plus B, cosine of that. It's the same triangle. It's the same angle measure, whatever A and B are. I don't know what they are, but I know it's the same. All right, and then the last example. Oh, no. We're going to do identities? Yes, we are. Darn tootin'. We are actually going to get done a lot earlier than the other period. So I really screwed around in that one. You don't do nothing, you do something. You don't just sit there and, oh my gosh, this is a monster. Okay, so it wasn't highlighted, obviously, in the book. So when you look at it, it's like, oh my gosh, what do I do? The point of the highlighting is you chunk your information together. Oh, if I just look at the yellow, this is the sine sum rule. So for me to do something, I'd write what? Okay, ready, set, go. What do I write? Sine what? Pi over 6. Then what? Theta. Then what? Plus. Those that have not said anything up to this point, you make me angry. I do sine theta, because wait, I did sine pi over 6, so now it's sine theta, and it's cosine what? Pi over 6. And then just for purposes of helping your brain see this, this is the yellow rewritten. Now what I have to do is go on to the blue. What's the blue? Okay, ready, set, go. Then what? Then what? Minus because of the identity. And then what? Sine, sine, right? Just sine, sine is all you had to say, and then I know what that means. Now, even with that being close to the end, I could still put equals, and all I'm trying to do is get this eventually. I don't have to keep rewriting it. Remember that's the rule? Okay, now what you have to do, and then just for the purposes of those being able to see the notes, that's the blue rewritten as far as the formula is concerned. But I'm going to go ahead and erase those. All right, what's the sine of pi over 6? This makes me angry. I actually asked you this at the beginning. What's pi over 6? 30 degrees, and then sine of 30 is what? You answered it. 1/2. If you need to draw a triangle, go ahead. Pi over 6 is a 30 in quadrant 1. What's the cosine of pi over 6? Not a half. What is it then? The other one. Root 3 over 2. And then that's sine of theta. Sorry, I was kind of confused. So cosine of pi over 6 is cosine of a 30 is not a half. It's the other one. Root 3 over 2. Now what's the cosine of, what's pi over 3? What's pi over 3? What angle measure? What's the cosine of a 60? Half. So then what does that make the sine of a 60? The other one. Now, I marked you wrong for not writing thetas when you're doing identities, because it's laziness, and you should be marked wrong for being a lazy bum. So just be aware of that. You will always be putting your hand in the fire. By the way, when you put your hand in the fire, what always happens? Fire doesn't care. Fire will burn you every time. On the fire. If you keep doing things over and over again that are lazy or not math syntaxically correct, you will consistently and constantly keep getting marked wrong. And if you keep doing the same thing over and over and over again, you are as silly as the person that puts their hand in the fire and gets burned, and then what do? Fire burn, fire burn, fire burn, fire burn, fire burn, fire burn. Why do I keep getting burnt? Because you keep putting your hand what? In the fire. Did I say good morning? Okay, who cancels? And then what's 1/2 plus 1/2? A full. And now is the time where you go, yep, I don't even have to rewrite the other side. You write it here, and you say something is equal to itself, or I will mark you what? Wrong. It doesn't stop short. You don't ever stop short. The last step is write the answer and then arrow that it equals exactly what the other side should have been. I don't know what else to tell you. It's all about the work in the middle, though. That was only a 3-stepper. I'm not even going to try to do what I did last hour. I tried to make a complicated example and got real bad.